So, okay, so let's set up a real simple movable pivot really quick. So let's just do a file new. I don't need to save that. Okay, so I'm going to create just a polygon cube. I'm going to create a polygon sphere. Fantastic modeling work. Okay, so we've got two objects there. So what we're going to do is we want to have it so that, I can take this box and, anywhere that I rotate it from, that rotation is going to affect my sphere. First, I should bring up an outliner so you guys can actually see what the heck we're doing here. Let's bring an outliner in. So we've got our box, and we've got our sphere, our ball, smashed. Okay, so what we want to do is we want to take and whatever we do to the box, we don't want the translation of our box to affect our sphere. We want just the rotation. So we want to, in effect, rotate it from different points in space. So the first thing we need to do is we're just going to unparent this, separate it, and we need to create an intermediary object. We need to create something that is essentially not going to move. So I'm just going to create a group node. I'm going to call it neg. And I'm going to put that underneath my box. And then I like to use, in order to make things easier later on, I like to use render nodes, using utility nodes for doing most of my real simple connections rather than creating expressions. It's more of a preference than anything else. So I'm going to just bring up a hypershade real quick. Give us a work area. Select our two objects. Bring them in. And let's create a general utility multiply divide node. Okay. And let's have translate going to input 1. And the output go into translate of neg. And then we're going to set this up so I'm multiplying everything coming into here by -1. So if I look at the position, it's not really what I wanted to do. The axis, there we go. If I look at the position of that direct child of the box, it's not actually going anywhere. It's just going to stay there. Now it's going to vibrate for some stupid reason, is whatever Maya's doing. But the node itself is basically sound. It's going to sit there and not do anything. Not do anything when it comes to the motion of this object, but it'll still get anything from its parents, and we'll kind of get into that in a second. Okay, get my channel box back. Okay, so the cool thing is, if I rotate, I'm still going to get that information through here. I'm only removing the translation. So if I take my ball, and I put my ball underneath the neg, my ball doesn't move when I move, but it moves when I rotate. So I can essentially rotate this from any location. Really simple to set up, just a couple of nodes. Now, what we did on the human rig was a little different in that we had a pivot actually controlling the position of the controller, and that's a little bit more complicated of a setup, but knowing this basic theory, you can kind of figure that out. Now, if you want to do something where instead of using rotation as your driver, you wanted to do the opposite, but you wanted to change the orientation of something. You wanted to have, you wanted to be able to rotate something in order to, say, reposition the orientation of a control, and then have the translation actually drive it. There's one extra step that you need to go in, you need to take into account. Let's start over and let's do a different repositional control. Okay, so starting here with a fresh scene, we're going to just create, again, we're going to create a quick cube, and I'm going to create a plane. Don't need too many divisions in the plane, we just need to see it. Okay. So we've got our two objects. Delete history, because I always do. And this is going to be our pivot. And it's going to be our object. Okay. So we're essentially going to start off and do the same thing that we did before. Is we're going to create, a negative node, something to have the inverse of our initial object's transformation. In this case, it's going to be rotation. So that's our negative node, and we'll take the two of these into into our hypershade. See what we've got. So I've got the neg, I've got the pivot, and we're going to create our multiply divide node again. This time we're going to connect rotate input 1, and we're going to connect the output to rotate. So if we take a look at the result, we've got our pivot, multiply divide, which we want to take all channels, multiply by -1, and then the output is on our neg node. So in theory, if I take my object and then parent it under the negative, when I translate, I'm getting everything through, but when I rotate, I don't. If I can grab the handle, when I rotate, I don't. Now, in a moment, you'll see the flaw in this, that as soon as I change axes, so it seems to work for one axis, but not for multiple axes. So one's fine, one's fine. So what's the reason behind that? Well, the reason behind this is rotation order. If we create an object and we need to translate it, let's just create a locator really quick. If I move something sideways or I move it up, it doesn't matter whether I moved up first or sideways first, I'm going to end up with the same result. With rotations, that's not quite the case. If I rotate something and then rotate it on that new axis, I end up with something different than if I rotate it on that one axis and then something else. Let's get that back. If you look at something, if you look at your rotations in gimbal mode, let's just move this out of the way a little bit. You'll tend to see what happens when the rotation order on this object by default is XYZ, I believe, and we'll just make sure XYZ. So essentially, if I rotate my Y, it's going to bring my X and my Z together. So I can definitely see that if I rotate X or Y or Z, that order is going to affect, because whether I rotated Y first will put the Z in a different position, or the X in a different position than if I rotated the X first. So what all this comes down to is, essentially think of it as winding and unwinding. So if I've taken my box and I've wound it, I've rotated in X, and I've rotated in Y, and rotated in Z. To get back where I want to be, I need to rotate in Z, then rotate in Y, and rotate in X. So we can do that really simply by going to our negative object and just making sure our rotation order is, if our initial object, our pivot object, has a rotation order of X, Y, Z, our inverse object needs a rotation of Z, Y, X. So if I go here and I set this to Z, Y, X, Z, Y, X, now I can rotate it on any axis and not get any result following through. We can even put this mode in world, and it doesn't matter. So I now have something where I can pass local translation through, but not pass my rotations through. Kind of a neat trick. Don't use this one very often, but if it comes in handy, there you go. Just as some food for thought, I wanted to show you some other places that I find these movable pivots really, really invaluable. I generally do, like a lot of people, some kind of a spline-based, system for my spine, which works fantastically. But if you need your character to bend over, you've got the multiple actions of, okay, so first I've got to bend it over, rotate it, and I've got to translate it, and kind of work with that. But having an extra parent above that, where I can essentially just rotate it, gives me a single easy way of FKing that, but I still get it, as an overall spline system. But I can also translate the position of this to get a different result. So again, another instance in where movable pivots are pretty valuable, allowing you to really animate the distribution the way that you want on a single node instead of across multiple nodes, or in the case of this, multiple actions, translation and rotation. Another place I find it useful is in something that has multiple actions depending on what you're doing with it. A foot, when you're walking on the ground, the pivot of your feet is on the ground. But if you've got a character that's hanging or just sitting on a chair dangling its legs, you're actually going to have a pivot around your ankle. So being able to control your leg from the ankle, could be a very valuable thing for a character that's flying or jumping around a lot. But yeah, then Maya on Mac. Okay, so I can set it back to have it on the ball, and I can even do things like automating the actual position of the pivot, so that with a single channel and knowing what's going on, we can actually have a pivot change to more intelligently allow someone to do an animation of a character walking without having to use the typical system of animating and unanimating, like reverse foot or something. But this is all done through using the same basic premise of knowing how to reverse out that pivot, and knowing that when your rotation is 0, I'm going to go back to kind of my character sitting here at the origin really quick. Okay. So we've got our pivot is on auto. Okay. Like in the initial example, when your rotation is 0, you can move your pivot anywhere. So knowing that you can do things like, oh, I can use the 0 point of my rotation as a flip point so that I can go back and forth. So if you needed something to kind of roll end over end, you can switch that pivot position as you cross 0. And other useful things like that. That's all I have for this evening. I hope some of this information is helpful. I can also make the recommendation to take a notepad and go to the zoo, bring the kids. Fun and informational. Take care.